The extinction that ended the age of dinosaurs is often reduced to a single moment: an asteroid, an impact, a sudden, irreversible shift. It's a clean explanation, but it isn't the whole one. Around 66 million years ago, at the boundary between the Cretaceous and Paleogene periods, a large asteroid struck what is now the Yucatán Peninsula. The impact released enormous amounts of energy, ejecting debris into the atmosphere and disrupting global climate systems. This event is widely accepted as a major driver of the extinction, but it did not occur in isolation. At the same time, on the other side of the planet, one of the largest volcanic events in Earth's history was already underway. The Deccan Traps, a vast region of flood basalts in what is now India, were erupting in repeated pulses. These eruptions released significant amounts of carbon dioxide, sulfur dioxide, and other gases into the atmosphere over extended periods. This did not produce a single effect. It produced instability. Volcanic gases altered atmospheric chemistry, influencing both warming and cooling cycles. Sulfur aerosols could have temporarily reduced sunlight, while carbon dioxide contributed to longer-term warming. The climate was already shifting. The asteroid did not strike a stable system. It struck one under stress. This is where the dynamic changes. Because extinction events are rarely the result of a single cause acting alone, they emerge from the interaction of multiple pressures, each one weakening the system in different ways. The asteroid impact introduced rapid, severe disruption, reduced sunlight, cooling at the surface, collapse of photosynthesis in both terrestrial and marine environments. But in a system already affected by volcanic emissions and climate fluctuation, the capacity to absorb that shock was reduced. Resilience depends on stability, and stability had already been compromised. Some studies suggest that volcanic activity may have contributed to environmental stress both before and after the impact, extending the period of ecological disruption. This does not diminish the role of the asteroid. It reframes it. The extinction was not a single blow. It was the point at which multiple stresses converged. An already unstable system encountered a sudden global disruption, and the combined effect exceeded what life could adapt to in the time available. This pattern appears repeatedly in Earth's history. Not one cause, but several, interacting, compounding. Extinction in this context is not an isolated event. It is the result of pressure building across systems until they can no longer maintain themselves. The asteroid didn't act alone. It arrived at the moment when the system was least able to withstand it.